name is Mirko, coming from College of Applied Studies, Aviation Academy in Belgrade. Together with my colleagues, Mirko Maks, Katarina Martinovic, work on this paper following title, Residual Fatigue Life Estimation of High Pressure Pipeline Thermal Power Plants. Thermal power plants is an important part of the energy sources and one of the main sources of electricity, and to produce more energy for distribution to the customers. Important item in working life for thermal power plants is analyzing and prediction of failures and stagnations in system. In this paper, we consider the critical zones in terms of stress state or distribution and the determined procedure for prediction of life assessment and overhaul period. We know, especially in our country, that most of our thermal power plants were built before 30, 40 years. And so it's very important in service life to estimate life assessment of critical parts. Structural elements as a part of whole system are exposed to complex stress states and loadings because of very complex working conditions. It's a very high temperature, it's very high pressures. Not only this parameter included in this work, we also have to take into account and the other conditions involved in the thermal power plant. And the subject of this paper is focused on the assessment of the remaining life of structural elements on the high pressure steam pipeline and the thermal power plant. In order to avoid steam pipeline failures, it is necessary to know the stress state under the influence of all expected loads. It includes internal pressure, distributed thermal expansion, flow, weight of the steam line, concentrated forces, and mechanical press-stressing loads. The entire calculation procedure shown here is pipe elbow. It's one of the most critical part of the steam pipeline. Under the code CL3, we take into account in this paper the number CL3 is elbowing in the thermal power plant Gatsko in Bosnia and Herzegovina. And we also wanted to point out that operating conditions for the main steam pipeline is temperature 545 Celsius and the pressure is 250 bars. When it comes to estimating the remaining life, it's necessary to use NDT methods to determine there is no damage to the considered structural elements. The material of high pressure pipelines is still the cost. Name of the material is very common use in thermal power plants. Equivalent in DIN is 50 chrome molybdenum, vanadium 5. Line 9. And thermal power plants involving critical loss of energy. Sorry. And to first step is to define accurately stress distribution in the structural elements. For this purpose, we're using the software package ANSYS, well-known software package in the world. A lot of huge companies in the world with that software. And we also have to know its advantage. The characteristic material is 50 mix 1 MAF. Pressure is 25 megapascal. Temperature is 545 Celsius degrees Celsius, and the flotation time in the previous period is 126,077 hours in service. That material is very famous. We also have to take into account the geometrical characteristic and also thermomechanical properties of that material, especially at the high temperature and very extreme value of pressure. It's given in table 2.9.1, 2.1.2, and 2.1.3. Temperature of critical points of the grade material, mechanical properties under 20 degrees Celsius in table 2.1.5. And also we have properties, physical properties given depending on the temperature in the table 2.1.6. Here is the first slide of the stress distribution. And given the geometric radius is 1,370 millimeters, and the outer diameter of the tube is 375 millimeters, but the thickness is 60 millimeters. It's very huge thickness, but according to conditions, it's normal. And this is a close view of the stress distribution on the figure 2.2.5, and we saw that the critical value is 73 megapascal, the maximum stresses. This is in beta view. And equivalent, talk about the equivalent from stresses in the elbow. The maximum value is 73 megapascals, but in our population, we take the safety factor 1.5. So, for this purpose, is developed in-house software, and value is 109.5 megapascals. Using the software packages for calculation of the lifetime of structures under thermomechanical load for stresses, I said previously, and the characteristic of the pipe elbow material, the lifetime for the concentric pipe elbow is around 19,404 hours, and the total lifetime of the pipe elbow is 146,000 hours. For obtained strain values to computed lifetime estimate to satisfy the condition to allow the extension of elbow life about 20,000 hours. It is approximately about 3 years. After 3 years, we have now again start calculate life estimation of the elbow. Structural analysis and the stress state analysis were performed in this paper using the software packages. The stress state obtained by the finite element method is more realistic and represents an improvement in relation to the application of stress concentration coefficient obtained empirically. Finite element methods also provide a more detailed explanation of in-series behavior of streamline elements. Also, finite element methods include to determine the critical zone, location of the stress concentration, high pressure pipeline. This computation estimates the determination that analyzes the pipe elbow within the high pressure pipeline meets the condition that its life can be extended approximately by 20,000 hours, which satisfy the necessary conditions between two overhauls. This is the life estimation of the structural element in thermal power plants. Is one of the crucial importance for defining period between two overhauls, and it is significant for saving time and money. Acknowledge this research has been supported by the research grant number following of the Ministry of Science, Technology Development and Innovation of the Republic of Serbia. Thank you for your attention, and if you have some questions for me, don't hesitate to ask me.